Notes lecture. And once again, this is going to be on a worksheet that I gave you here that has all Boyles Law and Charles Law, ideal gas law, combined gas law, all that good stuff. So today we're going to talk about gas. So let's look at Boyles Law. Boyles Law says that anytime you multiply the pressure and the volume of a gas, it's always going to stay constant. So if you change one of those two things, once again, the number is always going to be constant. So let's look at this. Got a sample of gas held at 1.2 cubic meters. Well, let's talk about what that cubic meters is going to be. That's going to be your volume. Then it says at 226 kilopascals. We're going to get used to these new units. Pascals is a measure of pressure. So this is your first volume. That's your first pressure. Then it says the temperature kept constant. While the volume is decreased, the pressure goes down. So here they give you a second pressure here. And it wants to know what the new volume is. So the formula we're going to use, it's like this right here. So I'm going to have P1 times V1. That's your first pressure and volume. Since it's always going to be a constant, it has to equal your second pressure times your second volume. So let's just plug in these numbers now. So I got a pressure of 226 kilopascals. Now, it really makes no difference what unit you use, whether it's pascals or kilopascals, as long as you use the same ones on both sides. And then I got 2.6 cubic meters. Over here on the other side, I have 565 kilopascals. And it wants to know what the second volume is going to be. Well, if I now divide both sides by 565 kilopascals, you end up getting an answer of volume 2, ends up equaling 1.04 cubic meters. So that's Boyles Law. And we'll do some examples of Boyles Law in the lab here coming up. And we're going to take some shaving cream and put it in a vacuum chamber and make it get really, really big. Now, the next thing we're going to do is Charles Law. Charles Law is, says that at a constant pressure, if you take the volume, that volume is inversely proportional to temperature. So therefore, as volume goes, temperature goes up, volume will go down. So that means that your first volume divided by your first temperature has to equal your second volume divided by your second temperature. This is always at a constant pressure. So this is Charles Law. And so now I have a container of 0.22 cubic meters. Once again, that's going to be volume. So that's volume number 1. Of nitrogen gas is placed at 20 degrees. Now, careful with this. So we got to do all these in Kelvin. So don't forget, we got to add 273 to every one of these. So this is temperature number 1. It's held under constant pressure, and this then heated to 167. Well, again, this is going to be temperature number 2, but we got to add 273 to that. Okay? It wants to know what's going to be your new volume. So let's plug in all our numbers here. Well, volume number 1 was 0.22. Temperature number 1 was 20 plus 273 to get it to Kelvin. Then we're going to take and we're trying to figure out volume number 2. And we're going to put in the temperature of number 2 there. It's going to be 167 plus 273. Ends up being 440, I think. So now we're just going to do cross multiplying here. So I'm going to do V2 times 293 has to equal V1, which was 0.22, sorry about that, 0.22 times 440. Let's divide both sides now by 293. And so your second volume ends up equaling about 0.3 cubic meters. Once again, pretty easy stuff. Just got to memorize these formulas. Now we're going to go down to the combined gas law. So let's just put them all together. Sort of easy. So if P1 times V1 equals P2 times V2, and V1 over T1 equals V2 over T2, and I can now combine them all together. It's called a combined gas law. And this gets a little tricky because you got a bunch of numbers to put in here. So let's do a 20-liter sample. Let's get that's volume. Liters is volume. Here is a gas at 273 K, so that's your temperature number 1. Is at atmospheric pressure. Well, don't forget, that atmospheric pressure was 101,300 pascals. And so that's going to be pressure number one. It's 101.3 kilopascals is what they're giving us here. That's pressure number one. The temperature is lowered to the boiling point of nitrogen. So this is temperature number two. The pressure is increased to 145. That's pressure number two. You got to figure out the new volume. So now we just got to plug in all these numbers. Woo! So let's put them all in. I got 20 liters. That's the volume. Times the first pressure of 101.3 kilopascals. Divided by the first temperature, 273. That's going to equal the second pressure, which is 145 kilopascals, times the new volume, which is what we're trying to find, divided by the temperature of 77K. Once again, it's going to be trying to figure out what the left-hand side is, and divide it by what the right-hand side is. You should end up getting 3.94 liters. Once again, I took all of this and got an answer and divided that by 145 divided by 77. That's how we did that. Lastly but not leastly is the ideal gas law, and then we're done. This is what I call the pervert, not pervert, but Pivnert formula. So I'm going to take P times V equals nRT. It says find the number of moles. Well, the N stands for the number of moles here, so that's what we're looking for, is N. And so it says find the number of moles and the mass of oxygen, of argon gas. So we're also looking for M. We'll talk about how to figure that in a second. And the mean molecular mass of argon is 39.9. I'll come back to that in a second. So let's look at all these pressures here. Now we're going to use these from the above problem. And so let's do 101,300 for the pressure here. Now we've got to figure out the volume. To get the volume, what we have to do is this. You got to divide the number of liters. So if I take 20 liters and there is 1,000 liters in a cubic meter, and all this stuff has to be in cubic meters. So the pressure has to be in pascals for this formula. The volume has to be in cubic meters. So this is always a little bit more difficult to use. So I'm going to put in 0.02 cubic meters for this one. I'm trying to find the number of moles. Now, R is a constant. It's always going to be 8.31. And shoot, my smartboard just locked up again. I'll be right back with you. All right, we're back. Sorry about that, smartboard locked up. And then we got a temperature of 273. So I'll put all that in. I am now going to solve for the number of moles by dividing both sides by the 8.31 and the 273. So I'm going to divide this side by the 8.31 and the 273. And that ends up giving me the number of moles of 35. No, it's not. It's 0.89 moles. Well, if you look up here in the problem, it says that each mole weighs 39.9 grams. So therefore, I'll put that in there. You multiply it all out, and you end up getting 35.6 grams for the total amount of argon or whatever the heck, argon gas we got. Hope that helps. Have a happy day. Love you a lot. We'll see you on the next day. Bye.